So next we have a presentation from Maria-Camilla from the University of Verona. Your talk is titled, Whose Fault Is It? Liability Profiles in Surgical Systems. Yeah.
Thank you for having me. I am privileged to be here today. I'm a PhD student at the University of Verona, and I work under the EU-funded project ARS, Autonomous Robotic Surgery. So I essentially do futurology. I try to imagine a path from where we are right now to where autonomous robotic surgery, fully autonomous, is possible. Okay. So the use of robots in surgery has been progressing. There are now very many procedures that are carried out robotically, robot-assisted way. Many surgical robots that are on the market right now have absolutely zero autonomous capabilities. And this isn't because we don't know how to. This is because there is a barrier in the regulatory and legal systems. We don't know how to interface, or we haven't interfaced yet, the technical aspects with the regulatory aspects. And so what has been implemented, what has been deployed on the surgical theater is surgical robots that can be viewed as mere tools. And they essentially transduce or transmit the signal, the control signal that the surgeon gives. It's a telerobot. And robots that do things that we physically cannot do, because they need to operate at speeds we can't control, or for example, to control radiation, the cyber knife and its prerequisites. So I'm interested in finding out how to overcome this block, because it's really preventing the deployment of technologies that exist. And one example is, for example, autonomous suturing. The machine does it itself. It's a part of the procedure. It takes a long time. It takes a lot of concentration, and we can do it better than humans already. So why is it not available? Why is access to a better average surgeon than the human surgeon? Why is this not available? Because we don't have predictable liability profiles. We don't have clear regulations. I'm going to put it down this way. There's two key issues. We don't have a computational correlate for some key concepts. Liability and responsibility for sure, but also things like autonomy or supervision. And then we have navigational difficulties. We are missing the language to describe how we're moving in these very large systems. So where do we look for answers? We look for answers in rigorous definitions and in architectures. This is a technical problem. It isn't a subjective issue. It's a seriously technical problem, but it lives at the conceptual level, and it requires a multi- and transdisciplinary approach. So, for example, let's look at autonomy for a moment. There are two very large families of ways to understand this. Why is this distinction important? Because in the proposed documents that govern AI, for example, this very large one, the proposal for the regulation of artificial intelligence that's been out in 2021, we do not have clarity on what words mean. So is autonomy freedom from incompleteness? I don't need you, I can do it myself. Or is autonomy freedom from interference? You can prelate my control signal, you can take over. And then the question is autonomy complete automation? We have completed the process of transferring the task to the robot. Or is autonomy something that the user gives the machine as it operates? In surgical robotics, we think of autonomy still in a rather primitive way. We have inherited this from the field of automatic driving. There are 6 levels of autonomy. There are other, of course, articulations of this. And please note that we are trying to find a way to navigate by making distinctions between who monitors things, who generates options, who selects the options, who confirms, who approves, and so on. This is a typical other way to present autonomy in a surgical system. We have a general understanding of how we distribute the task, and then we do task decomposition. The For biopsies or for brachytherapy, which consists in inserting thing with a needle, we have human doing one thing, the insertion, the surgical part, and the robot taking care that the insertion goes straight by rotating the needle. But these are, in a sense, a little bit artificial because the robot could do it all. And yet we don't let it do it all because of regulatory issues. And even the concept of supervision, when it's present in the technical documents, it really means very many different things. For example, for the military people, it's the last one. It's authorization to operate. It isn't like the supervision of a parent with a child. You get it wrong, I show you how it's wrong, I give you a feedback signal. It isn't taking over. I see you do something wrong, I take control over from you. So there's different paradigms, and this again is not clear in the documents, not because we don't have the concepts, but because the lawmakers and the regulators don't have it clear that the problem is articulated this way. It's a technical problem. So, for example, these are all the roles that I needed to distinguish in order to provide a computational correlate of what was written in the proposal. Typically, we think the patient and the surgeon are the humans in the picture, and then there's the machine, the surgical robot. But there's all these other roles. So we move from the human trusts the machine, the surgeon trusts the machine that it's working with, if it's autonomous or semi-autonomous, to a completely different structure. The patient needs to trust the system made of the surgeon plus the machine. The surgeon needs to trust the system. Even the regulatory authorities need to trust the system. So it's quite different. And it's also quite different because the regulatory authority needs to trust all of these components. And here we don't mean trust in the subjective sense, but it means being convinced of trustworthiness. So it's the objective element behind this. So we are using this document that came out in April 2021 to try and figure out the next step, one of the next steps between where we are and this futuristic reality in which robots will operate on humans by themselves, practicing medicine. I wrote here more slides than I can cover, but it's just in case somebody is interested. These are a few things. This AI Act is revolutionary because it is the first act the first proposal that goes beyond a statement of principles. It is actual regulations. These are the documents you need to present. This is the mindset in which we will evaluate your application. We are thinking of this as product certification. And there's a few things that we really need to pay attention to. This hasn't passed yet, but it's an expression of the largest regulatory body we have right now that has tackled the problem of how to certify artificial intelligence. And so the first element is auditability. There was an earlier presentation today about copyright, authorship. Auditability is about being able to trace the authorship of the final decision. And it's just as tricky as being able to solve the copyright problem. Who's the author, essentially? The second very big issue is that we are moving from component level requirements to system level requirements. And this is a big bomb. We must provide supervision and override for any machine decision, which means full autonomy is actually forbidden in Europe if this passes the way it is. And what do we need to do? The good thing we need to do is develop new architectures in which we can take in the human component. And the really bad thing we have to deal with is that right now nothing's safe. We have introduced 1 million entry points for errors, model mismatch errors between the human and the machine. So there are 3 huge liability dimensions to understand whose fault this is. One is the levels of autonomy, so the way things are interacting, the way the machine and the human are interacting. And the other 2 are seldom looked at. Can what the regulatory authorities ask us be done? And while the human has the advantage, and we still do, well, we can be done. We can supervise machines, but it is not a given that we will be able to do that. And I leave you with one conclusion, which is this is really the missing technology that allows us to do the next step. We need to figure out how to match models that are expressed by different embodiments, different ways of doing computation. And if we can do that, this will enable intelligible machines, machines that we can actually interact with without being confused. Thank you.
Thank you very much.
How do I stop sharing?
I'll ask a question. So you describe liability as being a sort of technical problem, whereas how we allocate liabilities is sort of political, and there are the ways that we do it. It's I guess in the sort of a patient safety context, like about who's going to pay for dealing with the situation if something goes wrong. So I'm just interested in unpacking a bit more what you mean by it being a technical problem as opposed to something which is subjective or where the politics are more visible.
Okay, there's always going to be a political component to specifically liability, but it's not the only component. Because in order to find out who we hold liable for something, we need to find out who is responsible for something, and then ask if that module, that subsystem, or that person is capable of bearing responsibility before the law. So if it's actually a person, whether it's a company or a human. So the problem of objective liability is the problem of objective responsibility. And that is the problem of being able to trace which part of the system is actually supposed to calculate what. So having defined clear interfaces, we need to expand a heterogeneous system and think of it as a mass in which we can draw virtual surfaces, and there's computation across these surfaces. And we need to be able to fully characterize the computation that is occurring across these surfaces. This is a purely technical problem. It corresponds to our intuitive idea of responsibility, and it corresponds also to a support for being able to make systems safe, because it allows you to trace errors. We need to learn how to build systems in which we can detect model mismatch errors, because that way we can correct them. Tough luck correcting a black box outcome. We can't do it. In surgical systems, we have some features that don't allow us to rely on what is currently being relied on. There's not enough data. The data that we have is not homogeneous enough. It's hard to obtain. The statistical risk formulation doesn't work. You either have too coarse data with experimental medicine, or you really can't associate a probability. What is the probability of finding a particular vein twisting and this way, as opposed to the concept of having a complete data set is meaningless, because we could encounter any and all variations. So this is really foundational. Looking at these problems in the surgical domain allows us to see where we have oversimplified elsewhere, the actual problem of finding out how to build this right.